Hello everybody. This is today's ODTN use case team meeting. Thanks for joining, even if I moved the meeting. This was done to ensure that we got some participation also from Spanish people that were on a holiday yesterday. So I hope you enjoyed your holiday. And let's dive in right away into the blog post. I'm in the process of making it public with Greg Cross. There was a few minor items and links to iron out, but probably tomorrow or in the next few days it will be published, and I will share the link with everybody. It's just in really the final stages. It's just we're making sure the page looks good and the image looks good and all that stuff. So I think by the time next meeting hits, we will have this published already. We don't have anybody from the TAPI call today, from TAPI today, unfortunately, since I moved the meeting. But let me address one of the comments that I've seen here. Yes, I think I will discuss moving TAPI northbound to 2.1 as soon as that gets released. I think it would be not a major effort because we have already a lot of stuff for 2.02 and the difference are not that many. It would be a matter of changing the models inside ONOS itself, updating them to 2.1. And
sorry, Andrea, one comment.
Yes,
well,
please
sorry,
go ahead.
you were not in the conference call, but the main idea is whether it would be possible to do this before it is released. Since it's in release candidate, the people were discussing that actually using it in ONOS could help polish the small details that we had in the previous version of TAPI. In the previous version, we had issues like we had lists without keys, and it's not supported in ONOS. We had naming issues because we were using groupings and containers with the same naming. So the idea here it's not to wait until they release to move it into ONOS, but to deploy the current release candidate in ONOS, so we could eventually help iron out the potential bugs towards the final candidate, the final release.
I see. Yes, believe we can do that. I need to. I don't know if I have the time to do it, but I'll send an email out to the group. And hello, Gary. And I'll send an email out to the group and discuss with Hiroki that I know did a lot of the TAPI to the 02 work on the northbound to see whether this can be done in a timely fashion. And let's say in the next 1 or 2 weeks. Let's put this maybe next week. Let's see. I'll send an email out and see. Okay. Yes, that's definitely something that we can do, and that was of interest because to see if the model compiled with the ONOS tools, and to see if we were able to use it inside ONOS itself. Was that the point?
Yes, the thing that we discussed. Even if we're using only a subset of TAPI, at least that it compiles and we could use it, it's already good, because especially for the northbound, we don't have the flexibility of using pure XML or skipping young tools altogether. In this case, we are limited to the RESTconf implementation, which is tightly coupled to the DCS and tightly coupled to the young compilations.
Yes, understood. No, most definitely. So this is and API with REST. Okay. Yes, we can. I'll send an email out to make sure this gets done in a timely fashion, at least, and find someone that can do it. Can somebody update me on this point here?
That was a comment from Karthik. Saying that, I don't know exactly the details, but TAPI it's supposed to be compatible with OpenAPI, I think, and Swagger maybe released 3.0. I'm not sure. And it's supposed to be some already pre-made or pre-tested. Don't quote me on this and just a gross idea. Files that allow a compatible TAPI to be also used by Swagger Open API. And the comment was it's not ready yet, but I think don't quote me on that, but I think that it's not directly affecting the use of the Yang model themselves.
No, I believe not. That's, to my understanding, that is an auto-generated Swagger API that, at least a Swagger binding that TAPI does, and that we actually don't use, so it's fine by us, I think. Okay. Last week, I think you guys unfortunately did not have access to results of the TAPI poll, and because, well, I didn't share them. So the results of this, we had 10 response, and 70% said that the two requests should be preferable, and just 30%, three people said that one request should be preferable. I believe then we will address and go for a solution of issuing two TAPI requests in the northbound and have the TAPI manager deal with properly translating the optical channel request into an optical connectivity intent, and the layer 2 request into a well, cross connect inside the transponders. Can anybody update me on the three connectivity
Yes,
services?
same here. This is Ramon again speaking.
Mm-hmm.
This was also discussed because it's also in line with what some people were doing, and especially, for example, in Metro Hall, is that you were mentioning that you had two options to trigger
Mm-hmm.
TAPI requests, including the
Mm-hmm.
DSR and the OTC. So basically, the OTC is when you trigger a service between a transceiver line port and a transceiver line port. But it was also
Client
interesting
side and line
the
side.
option. Line side, yeah, let's say line side to line side. Let's say that the service starts at the device, the transceiver device port. The other option is it would be beautiful if it would be interesting if we could also trigger the services at the photonic layer. That means, for example, triggering a service media channel or a media channel from a RODM port to a RODM port.
I see.
And this is what
Uh,
people call it photonic layer.
okay. Yes. So what? This is interesting. I think that for now we can actually have this a bit out of scope in the sense that we can maybe do it for phase 2, but for phase 1.5 I would stick to two requests. Would that be okay for everybody?
That's fine for me. It's just more flexibility. In one case, the ingress device is the transceiver. In another case, you basically talk either to the OLS or, in our case, but it doesn't apply yet to ODTN, to the open ROADM devices. So it's okay if we postpone it for the moment. It's not an urgent thing, but it
Also,
should be flexible. We should be able to support this.
yes, but one point that I did not understand properly, maybe it's me that I'm just missing this piece. Are these three requests to be issued one after the other, or one is an option, meaning that you will always issue two requests, but you need to understand one or the other, in the sense that you will always issue the DSR request, or
Yeah,
and
it's a good
then
comment. It's a good question. I think that the sequential that you are talking or referring to does not apply to the photonic layer. It was more like a comment that it should be possible to do it later, even
okay.
if we could replace we could think of two stages combinations of those three. I don't know if I'm making myself
Mhm.
clear, but in one case, we could say we have a first stage, which is the OTC layer, and then you use phase 1.0 to do the cross connect in the transceiver. Another option could be also using the photonic layer, and then on the second stage, using the transceiver layer. But it's orthogonal question. You're right that we were not referring, or we didn't discuss in detail enough to say whether these three are part of a potential sequence. I think not.
So,
Okay.
right, Ramon, I wanted to, when this came up, I was a little puzzled by it, but maybe one way to think. So I'm just going to say some things and clarify if my understanding is correct, because I have a question. So you can think of DSR as a client port to client port setup, OTSI as a line port to line port setup, and the photonic layer is like an input into the OLS to an egress port of the OLS system, right? Would that be a way of characterizing? Because I didn't understand what the photonic layer was last time.
Yes, that was what we met this week. So the difference between OTC and photonic is that in the OTC, basically you instruct your transceiver, and in the photonic layer you directly instruct your ROADM or OLS.
Right.
It's like the transport part of the network, and this is what hopefully the OTC has to be compatible with the media channel that you end up establishing in your photonic layer. But
well, exactly. That was going to be my next question, because so you're looking at the photonic layer again as the OLS is a just basically a black box with a bunch of ports on it, and so it's establishing a connection between one ingress port of the OLS system to an output port of the OLS system.
Yes,
and
definitely.
Right. Thank you. Okay. Now, the last point you just made was where I was going. When one sets up that connection, so it's basically doing a kind of a path computation of sorts or whatever in the end-to-end connectivity across the OLS between these two OLS ports. So it has to be done. Usually, that's done with knowledge of a set of frequencies that need to be dealt with in terms of impairments or whatever the available spectrum, and there's also spectrum availability that has to be dealt with as well. So I was looking for the comment that you made that the OTSI, when that request comes, it has to be compatible with whatever path was set up in the photonic layer. So would they truly be occurring separately? Follow what I'm saying? So the OTSI, you would need to be specifying the channel characteristics. The photonic layer at the, if you want to call it that, ingress and egress port of the OLS system. Normally that would be done in the context of specifying, finding a path, and therefore you need to know characteristics to provision that path. So would it really ever be done separately from the OTSI channel specifications?
I guess no. Well, it's feasible because you could always delegate the responsibility to the user of the API, of course, from the software, let's say, point of view. Whether it makes sense or not, it's a good question. Probably you're right that it's always tied to the OTC. But I guess that people were more concerned about the feasibility of being able to establish like big pipes or media channels in general from an OLS or from an Open ROADM network perspective, regardless of what you end up putting in the ingress port.
Right. So what that would do then is that would constrain what the what would be available for OTSI provisioning then. If some channels, like you were saying, have been pre-provisioned in the photonic layer end-to-end across the OLS, then the OTSIs would be required to be tunable to that range and with those characteristics so that it could traverse the OLS when it launches.
And this is in line with the question that I sent by email. We still need to figure out how do we work with OpenConfig models to somehow tie up this tunability of the transceiver and to make sure that at least we can make the end-to-end path compatible with the tunability of the transceiver.
Yes, I was just coming to that at a later point. Do we want to go down there now and see what's the discussion?
As you wish. If you want to follow with your bullets, that's fine.
Well, it was just immediately after, so I think we can do that. So as you might have
I
seen,
will
there was
interrupt now.
Oh, hey Arturo.
Sorry.
Arturo is
Arturo,
coming.
sorry
Yeah.
for the delay. for entering. I was in another call and then ends a little bit later. Sorry, go ahead. I was listening.
There was this discussion on the software thread regarding the OpenConfig discussion that we were having also now. So I'll let Ramon talk about it, and then I'll give my opinion, and I'll let everybody join in the discussion.
Yeah, it's a bit, if I may, it's a bit in line with some issue that I've been raising in previous conference calls. It's because we are willing to use the already existing optical connectivity intent that it's in ONOS. As you may know, the ONOS optical model basically already takes into account the fact that we can have the so-called OCH and OMS ports to simplify things. And it's able to provision an end-to-end light path, taking into account at least some basic understanding of what a lambda is. And it does this because when you discover the device, it queries the ports of the. In our case, we're using OpenRODMs, but it's the same if you draw a big potato and you consider your OLS, and then you have your ingress ports. It's basically the same. But if you see this as a big device, ONOS already existing core would first query for each device or OLS system which wavelengths or OCH signals, for a lack of a better term, are available in that port. My understanding is that if this is in the context of a RODM, it means what OCH signal it can switch. And if it's in the context of a transceiver line port, it means ideally what can be tuned in that port. So basically what ONOS does is it queries on a port per port basis all these signals. So it ends up buying a resource database saying this port for this transceiver can tune this OCH signal, OCH signal. Every OCH signal is characterized by a central frequency and a slot width. The way people are doing is they are declaring the minimum slot width that you can work with, and then you will figure out how many slots do you need for a flexi-grid. And what ONOS does is it finds the shortest path between ingress and egress ports, and then it checks out of the database of OCH signals, which is the first fit. And once it computes the end-to-end, it performs a routing and wavelength assignment, and then it finds a path, including devices and ports, and the OCH signal, which for simplicity, it's the frequency. And at the provisioning stage, it's going to ask that question, that device to, okay, you can now set up the flow rule that you have this OCH signal. And for each OpenRODM or OLS, it will also send a new rule saying you have to cross-connect the incoming port OCH signal at that frequency and that slot towards that outgoing port at that frequency and that slot. It can be for an OpenRODM or for an OLS system. This is in very simple terms, the mechanism that ONOS has now. And we have been able more or less to make it work with an OpenConfig/OpenRODM system, but they are perfect in the sense that they can tune the C-band in their line ports, and their OpenRODMs can switch any frequency slot that you put in their input. Now the question is, how do we map this to ODTN? What basically we need to follow this reasoning is we need to be able first to extend the drivers so the driver can answer the question what wavelengths or what OCH signals you can tune in that port. And this is something that we don't know how to move on, because it is not clear from the status of OpenConfig models how do you retrieve the tunability capabilities of a terminal device or a transceiver. You can make assumptions. You can say, no, it's already pre-provisioned. There are already a list of optical channels pre-provisioned in the device. I can make assumptions regarding these so famous working models that it's like a opaque 16-bit code that it's magically known between the provider and the controller. And the fact is that sooner or later, if we want to work as ONOS pretends, we have to somehow reply to the question, which are the wavelengths available? And we don't know how to do this. And the second question is, once ONOS magically has, we can improve the algorithm. You can take into account as many parameters as you want, but the end result of the RWA problem is that you end up have a path and a wavelength. And the second is when ONOS requests me to actually set up and I have to configure the device, what does it mean in practice for the ODTN OpenConfig terminal device? It means that we already have predefined OCH signals with frequencies already predefined that are already supported, and somehow the provisioning is just turning that on, or how do we move on from here? And this is a question that keeps on arising, and that I agree with Arturo that we should sooner or later find an agreement in order not to block. So that's a very fast synthesis. If you have questions, I will be happy to answer.
Well, that was a great overview. I appreciate hearing that detail. I'll listen to the call recording and to be sure that I got everything. But I think it addresses some of the questions that I've been having. But just in general, in terms of polling the devices, so it sounds like it's a question of what the devices actually expose, right? Because you can iteratively, I mean, in the worst case, this is not elegant by any means, but one can just, ask and get a response whether the device can support this. Right, you can pull the device. So if you're looking for a certain uh, uh, set of tunability parameters that are required to provision a service, then the device can just be simply pulled. The question is whether the information is being provided, will be responded by the device. Will the device provide that level of discoverability? So is that kind of what the stopping point is what the
Yes,
device
you're
is
right.
willing to expose?
Yes, you're right. And the second sub-question to your comment is, how does the OpenConfig terminal device model, in terms of already existing published YANG, support that querying? One philosophical question is, how can I poll the device for that tunability? And then the more practical question, where in the model and in the XML I can find that information?
You store it,
That's
right?
Yeah. So we have maybe I will let you the time later on after the conference call to reread the email and to process Arturo's. But the question is, we have already some potential workarounds, but it would be great if we could have an agreement, and vendors' involvement is key in this sense, because we can always say, well, we know that the device will announce at least a list of operating modes which are somehow opaque, and that operating mode is already including a frequency, a FEC, whatever transmission option you want to think of, and it's already pre-known in advance. So I can, if I'm implementing the SDN controller, I can query the device can return to me the different operating modes, and then somehow in a preloaded table or some magic knowledge, I can fill in the different frequencies that the ONOS is expecting because I had that information. That's a way of saying it. Other options are, I'm assuming that there are already optical channel components. I'm talking about using a bit of OpenConfig terminology. I'm assuming that there are optical channel components in the device instantiated already. So I can just list them, and for each of them, I can get the central frequency. So at least I can assume, ideally, that these optical channels represent the tunability of the ports. It doesn't need to be like this, but it can be an agreement. And there are other options that you can still play with this field and that field, but we still don't have a clear answer. So that means we still are asking the question to vendors, how do I retrieve from your device your tunability, as in the ability of selecting a central frequency and a slot width? And second, answer this in terms of the OpenConfig XML that I'm querying. Then once we have this and ONOS does the RWA, the second question is, what do you want me to send as XML? So you end up tuning to that frequency. And this is, as you said, the question is about what the device exposes, and more in concrete terms, in terms of OpenConfig model.
I will say that for the first question that you you have raised, and there are multiple possibilities. I think that you listed the main ones. I have been thinking about it deeply, and I think that there are three that are available right now without, let's say, modifying the current model. So first option, it will be the one that you are mentioning. I think is the most straightforward, that is that the device is exposing the set of optical channels that are potentially tunable into a line port, let's say. So there is all the possibilities created in the device, and then you just pick up one and you attach to the line port, and that's it. Second option is that the information about the grid and the tunability of the line signal is within the meaning of the operational mode. Then here I have one question. So it is, can we assume that all operational modes within a device are going to have the same grid or tunability capabilities? This is one, I think, important thing. And the other one, and I think that it will be more complicated, is if every possible operational mode that you can attach to an open an optical channel can have different tunabilities, and this makes a little bit more complicated the computation because you will have different cases depending on the operational mode. And the third option, that it depends a little bit on the question that I made for the second assumption, is that you could potentially impose that all the ODTN devices that are implemented OpenConfig will include a property value, including the grid type of transmission and tunability capabilities. This is a placeholder that OpenConfig left for the definition of vendor proprietary information. So it's something that potentially we could decide all here in this community and say, we are going to, let's say, impose this and, let's say, ask him for this information as a property value within the device. This is the three alternatives that I see for, let's say, the first question. And for the second question, I maybe missed something about what you have been thinking, Ramon, but my idea is that as soon as you can select an operational mode that is somehow representing the type of transmission and the configuration of the central frequency for this optical channel, you will not necessarily, you will not need to configure anything else. So basically is that the configuration actions that you can do is to configure this operational mode and the frequency of the optical channel.
Yeah, good question. First of all, there is a problem with your initial comment that we could have pre-existing optical channels that are generic, because if you look, we cannot fix, of course, but if you look at the OpenConfig Young model, there is a leaf ref to the line port. So an existing optical channel that exists has to refer to a line port. So you cannot have, let's say, a pool of optical channels that exist and then you can instantiate it in, no, it doesn't work like that. And the second question is, yes, my understanding is to provision a service, ideally I would instantiate an optical channel component from the SDN controller. That optical channel component would include three main attributes. One would be the central frequency. Then it would be the operational modes. It is up to the reference document that you're working on to agree or not that those operational modes all refer to the same FlexiGrid and we work on FlexiGrid, or do you want to add additional constraints? That's up to you. And then the line port that this is attached to. As you said, this is mandatory, in my opinion, to instantiate the service. But the question is, this is not enough, because then, but this is also in line with the phase 1.0, as you know, you have to do the logical association between that optical channel and the ingress port or whatever logical channel you have in your system. So if we assume that we don't have a multi-stage system and we don't have many layers of ODTN or whatever, in very basic terms, you would need to create again a logical channel, an association, sorry, between your ingress port, which can be DSR or whatever, or Ethernet, and your optical channel. And this also has to be done during the provisioning. Was it clear, or maybe
No,
I
yes,
was not clear?
you are absolutely right. I was missing, let's say, the cross connection between client ports and line ports. For sure, this is a second part of the provisioning of a service, but I was trying to divide this in two problems. What like configuring the line, the OTSI signal in the line port. The second one, the cross connection between the line and the client.
Yes.
The proposal of the, let's say, transceiver reference design configuration that we presented last week. It was more or less addressing these two parts, let's say, sequentially, like two independent problems. But regarding what you mentioned of the first question, I think that you are right. It's like you will not be able to have this pool of optical channels, because then, for instance, you will not be able to attach one optical channel to two line ports. So then it's like one single frequency is blocking the possibility to attach to two ports. And this is a blocking point for this
Wait a
solution.
second. I'm sorry. I need to follow up, exactly understand what you're saying. Can you repeat this point?
Regarding the first alternative for the solution of the question one that I was proposing is that you have the pool of optical channels, and then you directly pick one of them. You configure the line port in the line port, let's say, field or parameter that the optical channel component has, and then you attach it to a physical port. The problem of this concept is if you will have a list of frequencies for a fixed grid, for instance, of 50 gigahertz channel spacing, you will have a limited number of optical channels, and then you will have one for each frequency. Then if you attach one frequency to one line port, you are precluding that you can use that same, let's say, optical channel or this same central frequency for another
No.
another line port.
It doesn't work like that. In my understanding, I can be wrong, of course, because my knowledge is limited as yours. But in my understanding, an optical channel component cannot exist detached from a line port. In theory, any compliant netconf agent should reject, because part of the OpenConfig line config is a leaf, which is a leaf ref. So basically, you cannot instantiate an optical channel without saying this optical channel is bound to that line port. Second, my understanding is that the same frequency could be used in different line ports, because the optical channel component would be hopefully different, even if the frequency is the same. So you would end up having two optical channel component instances or objects, so to speak, each of them attached to their line port when you instantiate. So in one case, you instantiate, this is optical channel alpha, frequency is F1, and line port is port 1. And you can send an optical channel beta, frequency is still F1, but the line port is Y or Z or whatever. And in theory, as far as I know, this should be possible. And then another comment is, my understanding is that initially the idea of instantiating optical channels is that at a given line port you could have at most one active optical channel. But as far as I know, it is not precluded that you may end up having multiple optical channels active in a line port for those devices that support having multiple optical channels transmitted on the same line port. This is feasible as well. So I don't know if
I
my
agree on the
clarification.
second 2 points. I agree on the second 2 points. The first one, I am a little bit, let's say, surprised. Maybe something that I missed. That if I understood correct, you say that an optical channel, a component, cannot be instantiated without the leaf ref to a line port, right?
If I'm in my understanding of Yang, if you have let's say a leaf that is a leaf ref, checking it right now. You have leaf target output power, leaf frequency, leaf operational mode, and then you have leaf line port, which is a leaf ref to a component slash component slash platform name description, reference to the line side physical port that carries this optical channel.
Mhm.
I don't know if it's feasible or reasonable to instantiate an optical channel without having a line port ref.
I didn't know that you needed to, let's say, fill this value. I mean, to have it present at the beginning, that you couldn't, let's say, configure it independently of the
I don't know.
creation of the optical.
Maybe I'm wrong. It's something to check
I doubt it.
because if we had this possibility of having the line port as an optional leaf, but usually when you have a leaf ref, it's rarely optional. It would mean that you could have like the tunability in terms of existing optical channels that regardless of the port, we're assuming that ports are homogeneous. And then once you instantiate, you use it in a port, but I don't think that's a reasonable assumption.
Okay.
So in short, after this discussion, my humble opinion is, while it is clear what are the processes that we would need to do to instantiate the service, which is allocating the optical channel, binding to the port, and doing the logical association, we still don't know how to solve the problem of tunability.
But Ramon, Arturo, the tunability is also related to the port property, right?
Yes.
And the property, as far as understood, is part of the open config platform part, where you have, as far as I know, for Nokia, some properties such as if it's C-band capable or L-band capable, properties such as flexi-grid or fixed grid, if it's reconfigurable or not. I'm trying to go in the open config platform of Nokia, the mean frequency of C-band, the max frequency of C-band, and all these and the states also. And these properties are associated to the port that where you in fact are going to configure your optical channel. So I think you have the capability to retrieve some level of tunability, as far as I see from now, by retrieving this information from netconf.
Dominic, this is a property that Nokia has defined, so it is, let's say, not standardized for everyone. So it's a property defined by Nokia for your devices. I don't say that it's not a solution. In fact, it's one of the three that I propose, but just to mention that this is not an standardized value or field that is within the open config models. It's a property defined with the name L-band, C-band, grid type, that you pick up and you yes, define it for your devices. So I'm not saying that this is not a, let's say, a solution, but this is something that we should, let's say, agree on, and it could be the potential solution for ODTN.
That was a bit my comment to Dominique. Thank you. To start with, but this is something that ideally we would not have to rely on. You can always add properties to components in a very generic way, the same way that we did with the ONOS index. And so we have room to somehow work around limitations. And probably what you just said could be a solution, as Arturo just mentioned. My comment was more whether there is already in the model a clear definition. Maybe it is. I cannot pretend to know by heart all the models, and sometimes between terminal device and optical transport, you skip thing. But there is an already existing standard, so to speak, information where this is encoded. And not only that tells me the mean frequency and the max, but also the tunability in between. If you have a reference saying, oh, but Ramon, I don't know what you're talking about. This is already defined and this young, that would be great if you could send it a mailing list. It would unblock us. And if, I don't know the details of the Nokia letter to document, but if you already have solved this, even if it's in a proprietary way, to the extent that you can disclose it, you can also disclose it in the group saying, Nokia, we solve it like this. And probably it can be adopted, and it should be even easier for you since it's done your way.
Guys, I want to just stop a discussion for a second and also think about the implementation itself. What I mean is that I agree that in the end goal we should receive this from the device, and I'm more than happy to continue the discussion along the lines of what you guys were proposing. For example, let's see what Nokia implementation is and see if we can use it. But I also think that we can, in some form, easily progress, choosing option number one, kind of hard coding every possibility that the port offers in a class in ONOS. I know this is not a long-term solution, but it can unblock us in the meantime while we progress the discussion on how we should get this information from the device itself. Any thoughts?
That would be a very reasonable approach for the intermediate. In what we would still probably, unless we find some placeholder that's already defined for this, we may still need some like a property tag, what you say, port line class A, and then you know that tunability of that. But we still need to pinpoint. That's a very good alternative for the short term, but we still need to pinpoint where to put that, the same way that we did with other agreements. I don't know if someone knows by heart the model, if there is already in the port component some place where you can put this label or tag.
Sorry, Ramon, I missed this point. Why do you exactly need this tag? Maybe it's me that I'm confused on this.
No, if I understood correctly, you would say that the short-term solution is that line ports are tagged with some class for which we already know the tunability of that port. Is that correct, what you meant?
Yes.
Then my question is, great, it seems like a reasonable short term. Now, the second part is, where in the model can we put that class and say, this is transceiver class, perfect. We can always use the property, or maybe there is some reasonable field in which that information can be encoded. That was just my comment.
Wouldn't the port ID suffice, be enough?
Port
in the
ID.
sense that each vendor knows its transceiver. And by knowing its transceiver, it will hard code in a class, okay, this port has these capabilities. And when that port comes up, we know that that port has those capabilities. In the sense, let's take Nokia example, okay? Nokia transceiver, port 1, everything. Port 2, some of it. But they know beforehand that that model does those things. Did I make myself clear?
Yes, but a couple of comments. First, we already had some issues encoding the port ID as an unsigned integer, and we assumed that it was a string, and then we had that ONOS index, so it was difficult. Now, what you say, it's perfectly feasible, but if we can aim for a generic ODTN driver in which this is true regardless of the vendor, to me it seems like a cleaner solution. So if we can say that in all vendors in ODTN can tag their port class by using this field, and then we can leave the class even opaque for the vendor. I don't care about that. But at least the more we can find agreement across vendors, the cleaner the solution to my. So if we can still use the port component, and then in some place, it can be the name, but I don't think the name is the right place because naming is very proprietary and usually it is not easy to use. If we forget the name, maybe something like an annotation, a property of the port, it's a very reasonable way to encode the port class. We don't need to solve it now. We just have it as a work item. Sorry.
Yes, I put it there. Any other comments?
I have a question. I mean, you will have, well, maybe this is true, but that you have line ports in your devices with different, let's say, transmission capabilities in terms of the tunability.
I wouldn't exclude it. If we have the simple way, we know that this is queried on a per port basis. We know that we can query this information from the device on a per port basis because we already are something like ONOS index or blah, blah, blah. If we can have the class which is different on a per port, I wouldn't exclude it. From the software point of view, it's exactly the same effort. Now, if we say that the reasonable thing is to have all line ports with the same class, well, it's already done. But why limit that if we don't have to?
Okay. Okay, I will say that if we are somehow making this assumption regarding the port types, I mean, if we need to, let's say, force everyone to make the inclusion of a tag within the device that identifies uniquely the type of port that it is, why can't we directly say, please define a property for E2 grid type, another one for the tunability or channel spacing, another one for what it is needed?
Because this is, you're already moving in the midterm. It's like when we realize that we don't have the information in OpenConfig, then what's the proper way? I guess that Andrea's suggestion was to use one simple tag that it's opaque without going much into the details.
Yes, but
of course, then you can.
I agree with that too, in the sense that if we have to do some sort of request to people to have this tag popped up by the OpenConfig models and the OpenConfig implementation, I would actually say that going towards a more full-fledged implementation right now could be done. And
fine for me. I'm open.
Short-term solution will be to directly make this port type. I mean, regarding the driver that you are using, that you hard code is on how the capability of tunability of the ports of that device is. But this will be maybe it's too, let's say, coarse, let's say, imposing. I will say directly to impose that from now all the ports has a WDM 50 gigahertz grid capability, and we move on. But it can be too coarse.
But I'm in line with that. You can say class A, 50 gigahertz fixed grid, class B, 625 C-band flex grid, and have these very macroscopic tunability classes. And we could even, I guess that we should also go a bit further and say, if this tag is not present, assume full tunability of the C-band, for example. And like this, we're more welcoming to other implementations. But I don't think we need to go much farther than what you just mentioned. 50 grid, fixed grid, 625, C-band, that kind of already predefined classes are fine.
And where does the modulation scheme
in the operational modes. That's already defined in OpenConfig. In OpenConfig, you have this 16-bit operational mode, and in the model itself, it already says explicitly this is I'm looking for the reference now, but this is a placeholder, so you can encode everything that you want to have in your just 1 second.
But that assumes a fixed modulation mode.
Not necessarily. You can have different operational modes, and the modulation format of each mode can be different.
Can it change once the port is defined?
It can change because. Sorry, Arturo. You can have multiple. Go ahead, after you.
Go ahead. I shut up.
My point is that a given port, as far as I know, could support multiple operational modes. So when you instantiate your optical channel component on a port, you specify out of that operational modes that you know that you can support, which one you're using. So for a given operational mode, it can mean a given modulation format, a given FEC, a given precode, whatever. And if later on you establish a second optical channel with a different operational mode, I understand that that second operational mode could also mean a different FEC, a different modulation format, and so on. At least this is my understanding of the.
I agree with Ramon. So basically, you have the list of operational modes that you can use, that are the possible modulation formats and transmission schemes that your line ports can support. That's what I was thinking, that the capabilities of all the ports should be the same, but okay. And then you pick up this selected operational mode for your optical channel that you attach to a line port. So that's why you can, by changing the operational mode of the optical channel component, you can directly change which is the modulation format of the fake schema or the baud rate even, depending on the richness of your operational mode definitions within the OpenConfig models. And well, there is this big flexibility placed here in OpenConfig on purpose by the people that has defined it, knowing that each single vendor has a proprietary fake schemas, and that let's say start to defining properties and values for each of these transmission formats. It will be maybe going to, let's say, be a problem.
I tried to paste it in the chat, but probably something went wrong. But basically it says terminal operational mode is a description, vendor supplied textual description, blah, 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 examples of this kind of info, symbol rate, modulation, differential encoding, state of polarization tracking mode, pulse shaping, FEC, and so on. So it's really a placeholder.
Can you put it in the discussion email? And guys, I'm really sorry to have to cut this short, but there is a meeting after this one, and I don't want to spill over that one.
Okay.
The ONOS TST. So my request is, I know everybody's busy, but I will manage to, and I will scramble around some people to make sure that the TAPI 2.1 gets tested with the ONOS compiler and all of that. So that's one. The second one would be these type of classes of the ports. Could somebody describe those in a way that then can be put into code? I can do the coding part. I just needed the proper description of all those classes, if you would say, of ports. Ramon, Arturo, Gary, somebody that has a clear understanding of what these different classes are, could put them into code, could put them into an email, then I'll put them into code as an enumeration or something.
Okay, thank you, Andrea.
Okay, I'll send a recap email on that, and we can continue the discussion next week. So thanks everybody.
Thank you all.
Yeah, this was a good discussion. It sharpened a lot of issues. So thank you very much for this.
Yes. Okay. Thanks. Bye-bye.
Thanks. Bye.